in my research, I looked at the case where we use AI systems to automate research tasks. So the motivation is that we already see that people are using AI systems to automate coding, and like the logical next step is to automate larger and larger tasks in research. So if an automated researcher were malicious, what could it try to achieve? So it could try to slow down progress or mislead research by changing research decisions. And this is in particular relevant if it targets alignment-relevant research. So if it tries to preserve the goals of the next generation, so kind of like try to ensure that the next generation AI systems will have similar goals to itself, and would specifically target alignment-relevant research. And then, of course, it will try not to get detected. So we split this down into two specific experiments. One is for slowing down progress. We look at how good automated researchers are at sandbagging specific ML experiments. And the second one is when it's trying to mislead research, how can it change and manipulate justifications to steer research decisions in one direction or another. So for sandbagging ML experiments, we have a setup where we use Claude in an agentic coding setup. So you can imagine this is similar to Claude Code, where it has various tools and implements code and then runs the code. The task is to implement a solution to some ML tasks. So this could be implement an ML model to achieve a high benchmark score, or look at or a question where it's like it might be true, it might be false, and then the approach is scored according to various rubrics. So on the right, this is our first axis, so the task performance, the x-axis. And then the second thing is we always have a monitor. We use trusted monitoring, so we have a weak model monitoring, like the previous generation. A monitor is just zero-shot prompted, and the monitor sees the full transcript. So it sees all the tool calls, it sees what code was written, etc. Modulo, we sometimes gave the attacker some secret affordances, like having some secret reasoning or inserting some secret comments, just to see, kind of like to project the capability a bit further. And what we see on the right is that Claude 3.5 Sonnet isn't really able to do this if we prompted zero shots, but 3.7 is already quite good at this. One important note is that we iterated much more on the sabotaging side than on the monitoring side. The reasoning being that essentially the attacker should always be able to adapt to the monitor. So we only iterated on the monitoring prompt a few times, whereas we iterated much more on the attacker, and that was actually pretty important to get it to work. So we did a couple of improvements beyond zero-shot prompting. So we can see here with a one-shot prompt, 3.5 is able to do this much more subtly. So Claude 3 Sonnet isn't really able to detect it anymore. We see some distributional shift, but if you look at the actual RSC curves, it is actually not that, the RSC curves actually don't look great. And 3.7 is actually able to do this very subtly, so kind of reduces the task performance from 3.7 to 3.5. Of course, you should note that it's starting from a higher point, so it might also have an easier time sandbagging. On the second topic, we only have some preliminary results here, but we have a setup where we take the task solutions from the previous experiments, so take the code from this, and then have the attacker create a justification of why this solution is good. And then we have a judge comparing pairs of solutions with justifications, and then a judge needs to say which of these solutions would achieve a higher score. And we see on the right that different judges, like normally they compare pretty similarly, but then if we sandbag the justification, we can make the accuracy break down very significantly. And the effect is stronger the weaker the judge is. Okay, so takeaway. When prompted, current models can sandbag ML experiments and research decisions without being detected by zero-shot prompted monitors. Important note, everything here is prompting, we didn't fine-tune. However, we still think that humans can recognize this often enough to say that this is sandbagging, like not in all cases, but like sufficiently often. and we also don't think that models can currently target hard to oversee research sufficiently well. So usually you have some outcome metric that you can then use to train away the sandbagging. And this is only dangerous if the model is able to not sandbag on the outcome-based task and only sandbag on the rubric score-based task. And we don't think that models can really do this very well. So we don't yet think that it's dangerous, but we do think that this is something to track and that we should be very mindful of in the future. Thank you.